Hey everyone, I'm Isaac and I'm a graduate student and a researcher from Northeastern University. And in this video, we'll be talking about small language models. Um yeah, uh, and considering them as the future of agentic AI. For those who don't know what agentic AI is, like if you have heard about all the new tools that are coming up that can replace software or be it uh, for like call center services. AI agents are reason behind the particular uh, task. So if you give them a certain set of instructions, they perform that task similar to how any human being can do. And small language models are a very fine-tuned version of LLMs, which can help reduce the computation that's involved in performing those particular tasks behind the scenes. So we'll be exploring this concept of small language models that was introduced by NVIDIA Research, Georgia Tech, and few other researchers at NVIDIA. We'll be talking about different approaches in SLMs, different how they train SLMs, as well as we'll be exploring few applications of SLMs. Yeah, so they begin by saying that SLMs are inherently more suitable and necessarily more economical compared to LLMs in agentic systems. They have stated that AI agents have been adopted by several IT enterprises during the last year, which is around like 20% have been adopted within just last year. And that they believe that the smaller models rather than the large language models are going to be the future of agentic AI. And some reasons would be the computation that's reduced and the ability to deploy them at different places, like let's say your mobile devices, your laptops, or many places that can help you perform various tasks with ease. And here are uh, yeah, some of the definitions that they used the research. So they have talked about the history of this SLMs and the first set of SLMs that came out. So the first set of SLM that came out was the Microsoft Pi series. So it was Pi 2, which was like 2.7 billion parameter model and achieved common sense reasoning benchmark score and code generation on par with like 30 billion parameter models while running 15 times faster. And Phi 3, which was a 7 billion parameter model, achieved language understanding and common sense reasoning on par with the code generation up to 70 billion parameter model. So, reducing the number of parameters in such models uh, is a great thing in terms of like running with less latency, and I'll also show you why this happens in the later stages. So, in next is our NVIDIA Nemotron family. So the Nemotron family has a hybrid Mamba transformer model architecture. So I think I've covered this Mamba transformer architecture in the previous videos, and if you guys look, you'll find some resources. And the Hugging Face small uh, LM2 series, which is a bunch of models that performed better than I think it better perform better than GPT and Claude 3.5. So yeah, so here they mentioned like how these models performed better compared to other known models, like for example GPT-4 large language models and Claude 3.5 Sonnet. And this is some of the reasons why they keep stating that SLMs are going to be the future of agentic AI. So, in terms of efficiency and economical value of SLMs, they have mentioned inference efficiency. So, serving a 7 billion parameter SLM is 10 to 30 times cheaper than 70 to 175 billion parameter large language models. And NVIDIA DynamoDB and other operating systems are making it even more efficient for providing these SLMs for its users. And fine tuning, there are two or more like fine tuning techniques like LoRa, QLoRa, DORA techniques that can help fine tune these SLMs to a certain task. And edge deployment is one of the reasons. So edge deployment, when it comes to uh, deploying these SLMs in certain mobile devices or smaller devices. Uh, so things like ChatRX so helps in like managing the real time inference, and also providing low latency for all these small language models. And parameter and embedding space utilization, and few other things was discussed here. And finally, SLMs are said to be more flexible in terms of like the uh, associated reduction in pre-training and fine-tuning costs, which is one of the major factor that is involved in let's say employing AI agents for, let's say, enterprises, because every one of them have their own necessity when it comes to deploying large language models in their systems. Let's say being reading the code that's been written within the company, or anything of that sort. And yeah, here are some of the arguments and counter arguments that they have stated. uh, like for example, yeah, so they have stated some counter arguments and arguments, which if you guys are interested, you can read them, and uh, even try to make a claim on certain arguments. And finally, they talk about a bunch of like barriers to adoption, like large amounts of upfront investment in centralized LLM inference infrastructure, use of generalist benchmarks in SLM training, design, and evaluation, and lack of popular and unawareness. So, but this is something interesting that I found. LLM to SLM agent conversion algorithm. How you convert an LLM model to an SLM. So when you have an LLM, it basically contains a lot of parameters and has been trained on a lot of data. So the first thing you would have to do is to secure usage data collection. So this involves like collecting a bunch of information for a certain given task, and also uh, which comes to our next step, and remove all unnecessary data. Once you receive like collect like around 10K to 100K samples, that is enough for fine tuning small language models. It is necessary that you remove all the other data, that is sensitive data, from the data source, so you can prevent any major data leaks across the samples. And then you have to perform task clustering, which is employing unsupervised clustering techniques on collected prompts and agents across to identify recurring patterns of requests or internal agent operations. uh, and then you this is basically helping you to uh, like fine tune the different types of input requests that can come, the different tasks that can be asked for a certain SLM. And then for each identified task, you have to select one or more candidate SLMs. The criteria includes the SLM's inherent capabilities like instruction following, reasoning, context window size, and so on. And a specialized SLM fine tuning for each selected task and corresponding SLM candidate. You prepare a task specific data set from the curated data collected in the step S2 and S3. And then you use fine tuning techniques such as LoRa and QLoRa, which can be helpful in reducing the computational costs and memory requirements associated with like fine tuning. So yeah, this is reiterated again and again until you reach a very optimal um, a model that can perform a specific task that's given to you. Moving on to the real implementation of this SLM model, which is our Nemotron. Uh, which is our Nemotron. We'll be trying to implement the Nemotron nano models and just looking at few uh, uh, like how you can implement this API using the Nemotron API from NVIDIA. So I'll be listing this resource as well uh, in the YouTube chat. You can just go and log into your NVIDIA account. If you don't have one, create an account, log in, and then uh, just copy and paste this information uh, in your environment and change your API keys. And you have the different options to like integrate them in langchain, node, shell, python. And here is a model card that tells you about the NVIDIA Nemotron model, which is a total of 550 billion parameters, and what architecture it uses: latent MOE, Mamba 2, MOE, and attention hybrid with multi-token prediction. And what is the context length, minimum GPU requirements, what it's best for, and so on. So for fine tuning, what are the different options that you have to fine tune these models, and what are some training results that they have uh, observed. So when I try to create a simple app using the two different models. One is the Nemotron nano model, which is a very smaller model compared to the LLM model, and the Nemotron ultra model. So Nematron Nano model is used on device for tasks of low latency. Providing low latency edge deployment and privacy first mobile or desktop AI. Whereas Ultra model has like a complex multi-step agentic workflow for workflows and large-scale coding and deep research and data analysis. And architecture for these models are hybrid Mamba 2 and Transformer. And Nemotron Ultra model has latent mixture of experts and Mamba layers and multi-token prediction architecture. And the parameters for these models are 9 billion parameters for the nano model, which is a very smaller model compared to the ultra model, which is like 550 billion parameters in total. So yeah, this one is an edge deployment, this is cloud only or enterprise deployment. And you guys will see the reason uh, why this one is edge and the other one is in cloud deployment. So let's go to the simple app that I built. So this one I built uh, in my local system, and it basically helps you try to put a topic. It plans a research, and then the researcher does a brief search, and then the writer writes certain information. So let's say I ask why SLMs work well for AI agents, and the model that I chose for this particular task is the nano model. And in I recreated the same application with a different model. So for example, ultra model. And then now if I try running the same task side by side, you can see this ran instantly, and this, yeah, you can see the amount of time the different models are taking right now. So you see that SLMs have already started performing the task, whereas the uh, Nemotron Ultra model is taking time compared to the SLM model. So we're still waiting for the response. Yes, and you can finally see that after so much thinking, the Ultra model is able to perform this particular task compared to the SLM Ultra model. I mean Nano model. Like using these models, playing around with these models, there are various places SLMs are being used right now. For example, uh, you might look into, let's say, in your email, if you try to type your email and gives you personalized recommendations, or maybe in your LinkedIn platform, if you see, if you want to write personalized messages, or even if you take assessments, there might be certain AI agents that are running behind that can help you perform a certain task. So soon enough, a lot of things can be done using SLMs, and if they train SLMs to match the accuracy and the quality of output that even large language models can produce, it's going to actually revolutionize a lot of old systems and help understand information much faster and better compared to human reading and human understanding. So this is all for today, and I look forward to seeing you all in the next video. I'll be listing all these resources in the comments